Hello, class. So in this video, we're going to do another example, and this should be example 2. Right. We're going to do another example of finding the domain of a function. This one is a little bit more complicated in a way because now we have two things going on. So look at the expression that we have. We have the function y equals the square root of minus 2x plus 2 divided by x plus 1. So now we have a situation in which our function involves the two cases that we have to worry about. Right? There's a square root, and we're dividing by an expression. How do you deal with a situation like this? Basically, just tackle each part separately. And that's it. So tackle each part separately. Okay. So for example, we can start with the square root part. So let me do a line here. Since we have the square root of negative 2x plus 2, we know this implies that negative 2x plus 2 has to be greater than or equal to 0. We can only use input values for which this inequality is true. Want to solve it for x explicitly, so we're going to do what we did in the previous example. Subtract 2 from both sides. And then here's where you have to be careful. Like the one thing you have to be careful when working with inequalities, since we have to divide by a negative number or multiply by its reciprocal to get x by itself, just remember that anytime you multiply or divide by a negative number, you have to flip the sign. So if I divide both sides by negative 2, I get x on the left-hand side. I flip the inequality symbol, and then I write what's left on the other side. And then, of course, negative 2 divided by negative 2 is just 1, because the negatives cancel. Okay. So from the square root part, we get that we can only work with inputs for which the input values x less than or equal to 1. Okay. Right, so in our domain, we cannot include anything greater than 1. Okay. So that's the square root part. Now tackle the division part. So let's do here. So since we are dividing, by, what are we dividing by? X plus 1. What do we have to do? Find the x values for which x plus 1 equals 0 and remove those. Okay? Okay. So I mean, this is a simple equation. You can probably see already what the solution is. Obviously the solution is x equals negative 1, but if in doubt, you can always just do the same thing we did before. We have x plus 1 equals 0. If we want to get x by itself, so subtract 1 from both sides, you're left with x equals negative 1. Okay? So from the fact that we're dividing by x plus 1, that means that we cannot have x equals negative 1 as part of our domain. So let's put this all together. To put it all together, the domain of y, and again I'm using y because that's the variable I used here. The domain of y is equal to the set of all x, and I'm not going to write element of the reals because again it's given that we're working with real numbers. So the domain is a set of all x such that, well, there's two conditions that the input values have to satisfy. Right? X has to be less than or equal to 1, right? And also, x cannot be, so you can write x or use commas. I think I've just been using x, the actual words for now, so let me use right hand. And x is not equal to negative 1, because that's what makes the denominator equal to 0, and we can't have that. And that's how you find the domain. So even if you have an expression that's a little bit complicated, like where you have square roots, combinations of square roots and dividing by expressions of x, just tackle each one separately and then make sure that your domain takes care of each part. So it's as simple as that.